Good day, guys. This is your tutor engineer. Today we'll be doing graphs in motion on one dimension. So let's start with today's lesson. The motion of a particle is described by the velocity time graph. Okay, the first question is question A. Calculate the acceleration in the time intervals AB, BC, and CE. Okay, as we've discussed a number of times before, let's write question A here. If you are given the velocity time graph and you're asked to work out the acceleration, you need to focus on the slope. Right, so in order to calculate the slope, you need to identify the coordinates. The coordinates at point B is 3 and 15, point C 6 and 15, and then at point E is 10 and minus 15. So if you want to put the coordinate at point D is 8 and 0. So let's calculate for AB. The acceleration is V2 minus V1 divided by T2 minus T1. So the coordinate here, remember, it's 0 and 5. So we'll say 15 minus 5. And then 3 minus 0 is going to be 10 over 3, which is 3.3. Okay, you can specify the direction and say in the positive direction. Now for point BC, acceleration V2 minus V1 divided by T2 is T1. In this case, you have 15 minus 15. Then 6 minus 3. So you can see that the acceleration will be 0 between BC, and then finally the acceleration between C and E is equal to V2 minus V1 divided by T2 minus T1, which will be, it's either you can use these coordinates or you can use a coordinate here. So you'll say minus 15 minus 15. Yeah, okay, divide by 10 minus 6. It's going to be minus 30 divided by 4. So that will give us minus 7.5, or we can just simply say 7.5 meters per square second in the negative direction. Negative direction. So that's it for question A, and then question B says calculate how far the particle is from its starting point after 10 seconds. So when they say how far from the starting point, they're asking for displacement. So likewise, we've discussed this before, that in order to work out the displacement, given the acceleration, so given the velocity time graph, and then you have to work out the displacement. You need to deal with an area under the graph. So we'll work out an area. Let's divide this between A and B and C and D, and so divide into four areas. Now for area 1, okay, so let's just write here. For area 1, you can call it change in x1. It's a trapezium. This is a trapezium. This side here is 5, and then the side here, the height in between is 3, and then that length there is 15. Okay, now let's kind of change the colors so that you don't lose track. So remember, we've got 15, we've got 3, we've got 5. So the area of a trapezium is half height A plus B. Our height is 3, then our area, so our A is the small side, is 5, and then the longer side is our B, 15. So here we have 3 area, sorry, A, why do I keep saying area? It's A, then our B is 15. So to simplify this, you'll use the calculator. You'll get 30 meters, right? And then change in x2, we're dealing with what? We're dealing with this area here, which is a rectangle. It is a base of 6 minus 3, which is 3. The height is 15. So we'll just say base times height is 3 times 15, 45 meters. Then change in x3. Change in x3 will be this area here. The base is 2, and then the height is 15. So since it's a triangle, half base times height. Base is 2, height is 15. So we're going to have 15 meters. Then let's calculate the final area, which is going to be this one here. The base is 10 minus 8, which is 2. The height is minus 15. Since it's a triangle, half base times height. Base is 2, height is minus 15. Remember the signs, because we are calculating a displacement, so displacement is going to be minus 15. So to answer the question, how far is the particle after 10 seconds, you're going to sum everything up. So we're going to say 30 plus 45 plus 15 minus 15. Then the answer would be, this will cancel each other. It will give us 25 meters in the positive direction. So let's go to question C. Sketch the displacement of the particle as a function of time. So let's plot a displacement. We have a displacement axis and a time axis. So this is going to be t in seconds, displacement in meters, So basically we can count in 20, 40, 60, 70, 80. And the time is going to be the same as our velocity time graph. We'll have 3, 6, 8, 9, 10. So 3, 6, 8, 9, 10. Okay, at 3 seconds, the displacement is 30. 30 is somewhere there. Make a point here. And then at 6 seconds, the displacement is 45. 45 is somewhere there. Make a point. And then at, is it 8 seconds, huh? What is it, 8 seconds? So the displacement at 8 seconds at point D after area number 3. So this thing is cumulative. When you plot in a displacement time graph, you need to accumulate. Remember, we said that the first point is 30 here, which is correct. Then the second point is supposed to be 45 plus 30, which is going to give us 75. So rather at 6 seconds, we're gonna go to 75. So let's just wrap off this point here. It's gonna mislead us otherwise. Okay, let's go back to the black color. So we have a 75 there displacement, and then at 9 seconds, sorry, at 8 seconds, we'll have 75 plus 15, right? So from here, this 75, you're going to add it to this 15, and then it's going to give us 90 meters. So, okay, just higher than 80. At 8 seconds, 90 meters is somewhere there. And then 90, you're going to combine it with minus 15, which is going to give us 75 again. So here we have 75. So 1, 2, 3, yeah. I hope we didn't mix up the times here. It seems we did mix up the times. So at 8 seconds is supposed to have been our peak. Sorry, this point here, this point, the 75 is here, rather. It's at 10 seconds, not at 9 seconds. So apologies for that. Let's wrap off this point. Okay, now let's plot the graph. Let's use the red color. So the displacement will be a curve from here, like a hockey stick. So this is actually a curve. And then between 3 seconds and 6 seconds is going to be a straight line. And then between 6 and 8 at the peak. In fact, the peak is supposed to be here at 9, right? No, I'm correct. The peak is supposed to be at 8. That's where the graph is crossing the time axis. So we are correct. So it's going to be a curve until 8, and then another curve until 10 seconds. So that's just about how the graph will look like. Let's try and fix this part of the graph. Remember, I said here it's going to be a hockey stick. It's not really a straight line. And then now let's do the final question. Sketch the acceleration of the particle as a function of time. So let's plot the acceleration. So the acceleration, remember, we've already calculated the values. We got 3.3, and then we had 0, then we had minus 7.5. So let's make sure that you're able to accommodate all the values. Let's rather put the time axis right here. Okay, let's say 3, 6, 9, even here minus 3, minus 6, minus 9. The time is 3, 6, 8, 9, 10. The first acceleration, remember, 3.3. It will be so for 3 seconds, right? So we're going to, okay, let's just change the color to black. So 3.3 is somewhere here, just above 3 for 3 seconds. And then between 3, I think between 3 and 6, acceleration is 0. So it's going to be 0. And then between 6 and 10, acceleration is minus 7.5, which is somewhere there, 7.5. So that's it. Here goes the acceleration time graph. You can just label, or you can just hatch the area. We've come to the end of our today's lesson. If you like today's lesson, please hit a like button and subscribe. Stay tuned on the next lesson. Cheers.